Imagine standing under a silent night sky, gazing at the twinkling stars, soaking in the peace. But in the very next moment, everything from the ground beneath your feet, the moon overhead, to the flow of time disappears in a blink. No explosion, no warning, only absolute nothingness. And that is also a scenario for the end of the universe. What could wipe out everything like that? Is there some invisible force silently counting down to annihilation? Let's find out in today's video. How will the universe be erased? To begin, let's travel back 13.8 billion years ago, when nothing existed. Space, time, and matter were all just a singularity, a point with super dense mass, unimaginable heat, and energy beyond comprehension. Then came the grand event called the Big Bang, which gave birth to everything. The universe began expanding. As temperatures slowly dropped, particles bonded, forming vast galaxies, countless burning stars, and endless planets, including Earth. But more surprising was that the universe isn't just expanding, its expansion is speeding up. Normally, the gravitational pull from giant galaxies should slow this process down. But instead of being held back, matter kept speeding away, as if something was pushing it. Scientists call this dark energy a mysterious entity that makes up 70% of the total mass energy of the universe. It was discovered in 1998 when two independent research teams published observations of Type 1a supernovae. The results shocked everyone. Those explosions were dimmer than expected, meaning they were much farther than previously thought. This proved that dark energy was silently pushing the universe to expand faster and faster. And it's this invisible force that may lead us to a terrifying future called the Big Freeze, also known as the Cold Death. Under the influence of dark energy, galaxies will continue drifting apart uncontrollably until the distance between them becomes infinite. At that point, the universe will fall into complete darkness, with no remaining heat or light. Space will become a boundless emptiness, where all life is erased and time seems to lose meaning. But some scientists believe that the Big Freeze may not be just a cold forever. There could be a scarier version called the Long Freeze. Unlike the classic model, this theory suggests dark energy may weaken over time, slowing the expansion. If that happens, everything could reach an almost frozen state, or in other words, completely stop. At that point, gas and dust become too sparse to form new celestial bodies. When no new stars are born, existing stars will age and die, and the universe will sink into eternal darkness. This stage marks the beginning of the degenerate era, expected to arrive in about 100 trillion years. By then, only remnants like white dwarfs, neutron stars, and black holes will remain, but even they won't last forever. Over time, most remaining matter will be consumed by massive black holes and might even vanish themselves. Around 10,000 trillion years later, the universe will enter the dark era, the final period before everything fades into eternal void. At this point, light becomes just a memory, and matter no longer exists in its usual form, only lonely particles drifting aimlessly. By then, nothing will be left to happen. If the Big Freeze is a slow death, then the Big Rip is a terrifying execution of the universe. Everything is torn apart in an instant. Galaxies ripped from their cores, particles broken down, and reality itself unraveling. As mentioned earlier, dark energy doesn't just expand space steadily, it accelerates it exponentially. Over time, this causes all physical bonds to shatter. You can imagine it like the universe being dismantled piece by piece. The first affected are the largest but weakest structures, superclusters with hundreds or thousands of galaxies orbiting and weaving together. Even the densest formations can't hold together. From within the Milky Way, the disintegration of those clusters would be the first warning sign of the Big Rip approaching. Yet humans won't notice anything until it's already too close. That's when stars on the edge of the Milky Way no longer maintain their orbits. They drift apart like fragments of a ship swallowed by an endless ocean. The night sky will no longer look the same. The glowing band across the sky will fade, then disappear entirely. The universe begins dissolving into the void. Next, the destruction speeds up dramatically. Planets in the solar system can't maintain stable orbits and begin spiraling outward. A few months before the final moment, everything will sink deeper into eternal darkness. Earth, the sun, and the moon lose their gravitational grip and drift away. Meanwhile, humans are pulled into the cold void, isolated in a universe falling apart. At this point, any structure still intact suffers immense pressure from the expanding space. Earth's atmosphere thins out from the upper layers. Geological activity becomes chaotic as the gravitational field shifts. A few hours before the final moment, Earth's stability vanishes, the entire planet breaks apart in its ultimate agony. In theory, humans might survive by recognizing the signs and hiding in ultra-small structures with minimized internal space. But that would only delay the inevitable. Soon after, even the forces that hold atoms and molecules together are overpowered by the expansion. Any surviving life is crushed from the inside out. The destruction continues. Even supermassive black holes, the densest objects in the universe, are worn down and eventually vanish. Then comes the final moment. The very fabric of reality, space, and time is ripped apart, marking the absolute end of everything. But is this horrifying scenario certain? The answer remains hidden in mystery. It all depends on a parameter called W, which determines how dark energy affects cosmic expansion. If this value is less than -1, then phantom dark energy appears. Instead of just speeding up expansion, it will eventually tear apart everything. Galaxies, stars, planets, even subatomic particles. But in reality, there is no precise way to measure this parameter. The only thing scientists can confirm is, if the Big Rip is real, the end is still far off. According to data from the Planck satellite published in 2018, this could happen no sooner than 200 billion years from now. That might sound far away, but its consequences for the entire universe and the physical laws we trust still puzzle scientists deeply. But what if the universe doesn't expand forever, but suddenly reverses? If life began with a big bang, it could also end with something just as explosive. This is the Big Crunch, a death no less terrifying than the others. When matter density reaches a certain limit, gravity takes over and slows the expansion. If this happens, galaxies, stars, and planets stop drifting apart and begin collapsing toward a single point. The universe shrinks. At first, the process is slow and hardly noticeable, but over time, the collapse speeds up and changes become more obvious. Galactic clusters move closer and eventually merge into massive, never-before-seen structures. Matter inside them collides, causing endless supernova explosions, heating up space dramatically. When chaos peaks, everything is thrown off its orbit, drifting in a shrinking universe. However, The clearest sign of the Big Crunch isn't star collisions, it's the change in cosmic microwave background radiation. This faint afterglow from the Big Bang gets compressed as space contracts, shifting toward the blue spectrum. Temperatures rise rapidly. Beyond what even the brightest stars can handle, they stop shining. Celestial bodies continue heating but can't release energy, eventually disintegrating. In the final stage, heat reaches extreme levels, breaking atomic structures. Basic particles like protons and neutrons fall apart, leaving raw energy drifting in a shrinking space. Under immense pressure, all matter collapses into black holes, while everything continues falling faster. A dark region spreads, swallowing all nearby matter. At the final moment, everything is compressed into an incredibly small point, a recreation of the pre-Big Bang state. But is that truly the end or the start of an eternal cycle? A branch of this theory, called the Big Bounce, was created to explain that. It proposes that the universe doesn't just rebirth once, but goes through endless cycles. After each total collapse, another Big Bang restarts the expansion. Some scientists, based on loop quantum gravity, suggest that space-time isn't smooth, but made of discrete units like quantum particles. When everything is compressed to the smallest possible size, a powerful counterforce bursts everything outward again. If this is true, then our reality is just one link in an infinite chain. Before this universe, many versions may have existed, and in the future, new ones will continue to emerge. But that's not the only theory for the end of the universe. Out there, as time ticks by, researchers continue imagining new ways for reality to end. Among them, one is seen as the quickest, most complete, and most terrifying: vacuum decay. If this happens, a deadly bubble could spontaneously appear somewhere in space, expanding at light speed and wiping out everything in its path. In this new vacuum, all physical laws are different from the ones we know. Galaxies lose their structure, atoms become unstable, and familiar things are erased. To understand this doomsday, we must understand its nature. We often think of vacuum as an empty void, but more accurately, it's a set of default states like settings on a control panel. When quantum fields fill space and remain at these basic values, we call it a vacuum. A small change in those values creates particles. For example, increasing the electromagnetic field creates a photon, but a big enough change can create an entirely new vacuum with different physical properties. In other words, if that balance is broken, the interaction between basic particles changes and the laws of everything collapse. Luckily, most quantum fields have reached their lowest energy level, keeping the universe stable. But one has not: the Higgs field. Imagine standing on a mountain peak holding a ball. If you drop it, the ball rolls down into a valley. The path is random, and it might not reach the lowest valley, just stop somewhere along the slope. Similarly, the Higgs field might be stuck in a false vacuum, not at its lowest energy. But what does that mean for the universe? The Higgs field gives mass to particles, influencing how matter exists and behaves. Thanks to it, photons have no mass, while the Z boson does. This field determines how our universe works. Still, it may not be truly stable. While other fields have rolled down to their lowest point, the Higgs field may be stuck in a temporary spot. That means our current reality may rest on shakier ground than we think. So what could knock it loose? Intense cosmic events or extreme energy bursts could be the trigger. At the quantum level, particles behave as both points and waves. They can pass through barriers that classical physics says they shouldn't. Instead of climbing over the mountain, the Higgs could tunnel through shifting to a more stable state on its own. If that happens, all of physics would be rewritten. Gravity might disappear, familiar particles break apart, and natural laws replaced by alien rules. If the Higgs field leaves its temporary balance and reaches its lowest true energy, everything could collapse in an instant. The bonds between particles would break, setting off a chain reaction moving at light speed, sweeping everything away in a catastrophe called vacuum decay. Wherever this bubble spreads, the laws of physics reset from zero. Even if life once existed, it no longer matters. And the worst part is what happens next is completely unknown. Atoms, chemistry, and space-time might transform in unimaginable ways. In this way, a new universe is born, but whether it's livable is another question. Can humanity ever solve this mystery? That remains unanswered. For now, scientists only know that the Higgs field might be stuck in a false vacuum. If so, decay may already be happening slowly, over billions or trillions of years. And when it finally hits, we won't be able to stop it. After all this, do we truly understand the fate of the universe? Whatever the answer, one thing is certain. We are tiny beings, existing for a brief moment in the vastness of time. And perhaps, instead of worrying how the universe ends, the more important thing is to enjoy the journey we have, because no matter what comes tomorrow, today is still a miracle.